questions?
Yeah, this might be very naive, but it seems to me there's kind of a really obvious difference between simulations and experiments. In an experiment, what you're normally trying to do is kind of somehow generate some new data. Then you've got a theory maybe, and it makes a certain prediction, and you just don't know what the fact of the matter is. So you kind of do an experiment to see what the fact of the matter is. Whereas in a simulation, what you're trying to do is just trying to get the theory, tweak some parameters so it fits already existing data. I think there's quite a profound and obvious difference there, or is this somehow very naive?
No, I mean, you do make predictions.
Simulations try to new data all the time. We use simulations of climate to find out what the future climate's going to be like.
Well, that doesn't seem to be what's going on here, but at least in the case of these cosmological simulations.
Well, you do make some predictions for, further statistical properties of distributions of galaxies, for example, that you cannot currently measure, but you will be able to measure in the future. So you measure at the moment, the only statistics we can robustly measure are what are called two-point functions, which is correlations in spatial position between any two pairs of objects. You can start doing 3s, 4s, 5s if you had enough statistics. And that's a prediction from the simulations. That's not observationally tractable quite yet, but very soon.
You have this picture up here where there was like a zoomed-in version and then a big version, and one picture was just like the dark matter, the simulation, and then the other was like what we observe and all the light and everything. I thought you were making a more specific point, not generally about simulations not being a good way to know what's going to happen, but that these particular simulations were something cooked up about them. Is that?
Yes, the point I was making was that there are several other steps after completing the simulation to actually compare with data, and that there's a lot of ad hocness in those steps.
So what do you start with? I mean, what do you get before the ad hoc stuff comes
The dark
in?
matter distribution.
So, but not that picture. The picture that looked so much like the observation.
You got the one that you saw in the lower panel.
Yeah.
And the upper panel is derived from the lower panel.
Okay.
By assuming that wherever you have mass, you have light.
Mm-hmm.
And there's a particular relationship of how mass and light are distributed. So the top map was derivative. It was derived from the lower distribution.
I mean, but in that case, the problem isn't so much with the original simulation, it's with these steps that are going in between the simulation and
Yes.
constructing the second image.
Absolutely. So the question is that, as a tool, how effective are they? How predictive are they? If, at the end of the day, to bridge the gap between what is observed, reality, versus the output of the simulation, some ad hoc assumptions have to be further made. That was the last point.
So the hope is something like that you can have a more worked out theory about the connection between the
Yes.
dark matter and the regular matter or whatever, and so,
Yeah.
okay.
And then, the way
So
forward
it's
would
not,
be.
sorry, it's not a criticism of simulations,
No,
it's
no.
more saying we need more theory.
That's right.
Yeah.
It's a statement of the status of how well understood this theory is, or how validated this theory is from simulations. Cosmologists would claim that n-body simulations validate the Lambda CDM model entirely, or to a very high degree of precision.
Yeah, I didn't understand the response that Eric partly made, and seemed to agree to the first self-described naive question. So I also have the same response. I mean, there's a sense in which the information you get when you run a simulation is new, but of course it's being new in the sense that it's being extracted from the information that you put in.
Right.
Whereas when you're doing an experiment, you're getting information that's new, but not being extracted from the information you put in. Nature itself is telling you something. It seems an obvious distinction.
Yeah.
Right, and I don't know no one was meaning to deny this, right?
Yeah, and that's what I mean by materiality. I think.
Well, it's not just materiality though, because look, take the toy tub. In the toy tub, you're not putting anything in. Nature's giving you all the
No, you're
information.
you're
But
choosing
would
to
you
put
call that an
water.
experiment or a simulation or just a model?
You're putting
She
water
say
in.
materiality, but you don't have to take too literally. Of course there is an obvious difference. There is a difference between a
No,
dog
the
and
question is what's the
simulation.
epistemic difference? I mean, I know there's differences.
It's a false dilemma, right? If I want to understand the tides, and like Galileo, I make a small tub and slosh it around. I'm doing an experiment on the tub, right? That's just an observation of the tub. That's data about how water sloshes
And you
around
can
the
choose
tub.
water or
And then there's a
glycerin.
second part, which involves a theoretical.
You don't know whether nature is satisfying the Poisson equation.
That's
She
right.
won't necessarily get what the Poisson equation predicts. She'll get whatever the Poisson equation, plus her approximation, plus whatever possible physical failures that the computer might.
Right,
But all of that stuff, all that stuff just creates problems and it's extraneous. And what you're saying there is, well, we'd like to get a deduction from what the Poisson equation.
Well, we can't. There is no.
Well, that's right.
Right. Yeah.
Well,
I mean,
Well,
there's
no,
not.
there is,
There is, but it's not available to us
it's not
mathematically.
available to us.
Yeah.
Right, so, but in that case, we're trying to draw out the consequences of a theory. In the other case, we're making an inquiry of nature. So this is a very obvious distinction. I don't know whether the point is to sort of say, it's not a correct distinction, or?
And if you want to know how good a Monte Carlo simulation or some kind of discrete simulation is going to be to say a continuum thing, that's a job for mathematicians.
Right.
You prove theorems about
You
it.
prove theorem.
Well, unfortunately, given you don't get in a lot of the cases that you're interested in, you're unable to prove the theorems that tell you that they're reliable. So you're making guesses.
Or you do more simulations.
Yeah.
Or do more simulations. I mean, yeah. Look, if you could prove the theorems, then it wouldn't be simulation anymore. It'd be mathematics.
Yeah,
right?
that's right. So simulation is a way of getting the same results, or results we think are close, maybe, this of course empirical matter, close to the results that we would
Yeah,
get.
that's the point. It's important. That's an empirical matter.
Sure,
Yeah.
but that's
Yes.
a different empirical matter from the empirical, when we're asking a question
Right.
about, is it an
And
acid
spelling
or a
it,
base?
I think
and
spelling
things
out
of this
exactly in
nature.
one sense, it's a different empirical matter. It's
I mean,
tricky,
that-
it's a different thing.
You can, suppose you want to know whether something's an acid or a base. Well, you can do a simulation. You simulate what would happen if it was an acid, what would happen if it was a base. But I want to know whether it was an acid or a base.
So I actually want to come back to.
Sure, but it doesn't follow from those considerations alone that there's going to be an epistemic privilege in cases of experiment. That's the question. What's the epistemic difference? You're getting, there's a difference. What's the
Privilege is different from.
Yeah.
Information.
Privilege is different from.
Or epistemic
difference.
superiority?
There's
right.
certainly a difference.
Oh, there's different, sure.
Well, a superiority. I mean, if you want to, you need both of these things to find it, to draw out the
It
consequences
seems
of
like
the
they're playing
theory.
completely different roles, so I mean, that's not.
No, but I mean, I think maybe it might be useful for me to react to 2 points that you raised, and that may help in clarifying this discussion. I think one of the reasons why I think experiments are privileged, I mean, the reason for making that comment is that it leads back to why I think the uniqueness of the universe is an issue. The uniqueness is an issue because at the end of the day, we are comparing statistical properties from a realization of one deterministic input of a fluctuation spectrum. So if we don't have access to the probability distribution function of fluctuation spectrum, and if I would have that if I had information access from many different universes. I would make that PDF, and then I would draw from that PDF successively, and then I would have an extremely well-characterized, description of the statistical variation from realization to realization. I don't have that now.
You never have that with historical explanations, though.
Yeah, so coming
So
back
I'm
to
not
historical
sure why that's-
explanation.
yeah.
So, but
Especially
I don't
cosmology.
understand what you mean by historical explanation. I just don't think for cosmological data, a historical explanation can give you the kind of quantifiable information that we're after. Could you explain what you
Why
mean?
did these kinds of clusters form, or why did these kind of structures form, actually? And you want a historical explanation of that, don't you? Why did John F. Kennedy
No,
die?
you wouldn't.
I mean, you want an
no.
explanation of that, you can give historical explanations.
No,
You're
but I
never
mean-
going to have
No,
the
but
kind of
science does
probability
not
distribution
ask
you want.
questions, right? I mean, science, cosmology does not ask a question of why this cluster exists. We know it exists, right? I mean, it's not why it
No, but
exists.
why the
Your
structure's the way it
example of
is.
quantitative questions.
We want
What's
quantitative
the
questions.
degree of uniformity in
Exactly.
the initial data, like 10 to the minus 5, that's what Priya said, or what's the value of the cosmological constant?
Constant.